So now we want to see how DOE looks in design space, in design space, meaning that how actually DOE can create this interaction, can find the interaction. Okay, we look at the golf experiment before. So in the golf experiment before, when we, let me show you, have this 4 factors. You have, let me put like this lah. Let me put in term of something like this, and then you want to lower the score. The response, you want to lower the score, and then you have 4 factors. You have 1, 2, 3, and 4. Okay, we want to focus only 2 for time being, because we want to see how the interaction happen in DOE. How interaction happen in DOE. So we want to focus on 2 things, which is first is a driver. The driver either is oversized versus regular, and also the second, the ball type. Ball type either is 2-piece and versus the 3-piece. So this is what we looked before lah. Okay, so in order to deal with these 2 factors together, DOE apply what we call factorial design. Okay, they apply factorial design. This is basically to say that you try to test 2 factors at a time. So that's what does it basically mean lah. Factorial experiment. Instead of varying factor 1 at a time, you vary factor together. Okay, so how it look like? So let me bring this thing. So it look like this. Okay, it look like this. Okay, so this is the design itself. So how it look like? Okay, you can see here. Okay, by the way, for the driver, we put this as lower. This is for example the level. So we have the lower level, low level, and also high. For the driver, we use this as a lower. Okay, and for the ball also 2-piece is a low, so we put here this is oversized, and also this is 2-piece, and the other one is ni lah. The other one is basically the high is regular, and also the 3-piece. Okay, so the 3-piece. So how the design happen in the space is basically you do this thing, you get the cube, because you have 2 level, 2 factors. You have driver, and also you have also the ball, and each one have 2 level, lower and high. So that's why you have lower for oversized for the driver, the lower one here, and also the lower for the ball, and also the high for the driver, which is regular, and also the high for the ball, which is the 3-piece. Okay, so how you perform the experiment is just basically you just what we call perform all the combination at this node. Okay, at this node. Okay, so this how you combine 2 factors together, meaning that you do it together. I mean, what does it mean by do it multivariable? Meaning that you do in such a way that you try all possible combination, low high, high low, high high, high low, like that. So you get like that. Okay, so you just play, you just put do the experiment on the node lah, on the nodes. So if you look here, you have 4 experiment or 4 round lah, meaning that if you play golf, you play 4 round lah, 4 round. So each round you choose this one, the oversized, and the tight ball is 2, and the second round you use this, the third round you use this, the fourth round you use this. Up to you lah which one you want to use, but after all you will have this 4 experiment. You have 4 experiment, but 4 experiment or 4 round lah. In the golf is 4 round lah, 4 round of golf lah. The 4 round, you can play more than 4 round. I mean that if you want to make it more powerful, you can play 8 round. 8 round, meaning that you replicate. What does it mean? When you play 8 round, you are double the amount that you should play lah. So this is what we call replicate. Okay, replication in design. Okay, because playing 8 round is not so tiring. It's just 8 round. So I think That's in this case, then we will play 8 round lah. So we introduce the replication. Okay, usually more data, better lah. More data is better lah. Okay, because you can screen the noise and so on. You can really say that, okay, this is because of this. The more data is better. So this is what we call replication. The one of the what we call the principle of the good design is you perform the replication to sort of like screen out some noise lah. Okay, so let's put some score on this design. Let me bring some score. Okay, let me bring some score there. Okay, so let me make it a little bit bigger so that you can see. Okay, so so this just a score. So because we do 8 experiment, you can see there are 8 for each, because 8 experiment mean that you have 8 lah. 1, 93, 91, 88, 90 and so on. So what here is the score. Let's say the score, this is golf score lah, but I just put it on this design space. So you have 8 round, so you have 88, 90, 93, 91, 92, 94, 88, 91. So this is the score. Okay. So this experimental design allow the experimental to study what? To study the driver effect. First, you can study the driver effect. I don't want in red lah. Maybe I put in blue lah. The first, you can study the driver effect. Okay. Okay, so how to study the driver effect? What does it mean by effect? Meaning that you want to see whether this driver, regular or oversized, which one is it matter to the parameter? That's what we call effect lah. Is this driver contribute significantly to the response? So how to do this is basically you just take because you have this type of driver here, right? And then also this is a high and this is the low for the driver. So what you do is that you take this, you combine this score on the right, you minus the score on the left. Okay, so you get what? So you will get, so let me put here, you get 92 plus 94 plus 93 plus 91 and then divide by 4 because you want to take the average lah. Plus the 4 and then you minus this thing, you minus with the left, the left or right? The left. So the left is basically you just do lah, you just 88 plus 91 plus 88 plus 90 divide by 4. So this give you the result of 3. Where to put lah? Let me put this sikit lah. Let me put here. So this will give you the result of what? 3. 3.25. You can calculate lah. But this is the result. Okay. So you find the average score on the right and on the left, and then you minus this together. So to measure the effect. So basically what you do is to measure the effect of switching from what we call from oversized, from oversized driver to regular size driver lah. So that the idea 3.5. You can also calculate here, from here, likewise you can calculate the ball effect. The same thing, but now instead of left to right, you want to minus the highest effect of ball. So for example, this is the highest, the blue one here, you minus with the another blue here lah, okay. So basically you the top one, left, right, it's basically from the high level minus the top low level lah. It's basically low level. If you do other way around, it's just you get negative lah. Okay, ball effect. So the ball effect, you just repeat the same thing. So you get 88 plus 91 plus 92 plus 94, and then you divide by 4, and then you minus with 88 plus 90 plus 93 plus 91 divide by 4, and then you get what? You get 0.75. You can see or not? We cannot see there. Let me bring a little bit here. Wait. Let me bring a little bit here so that you can see there. Okay. So you get 0.75. You can see. Yeah, you can see there. Okay, so that's driver effect and ball effect. You can also check the interaction between the driver and also the ball. Okay, so how you to calculate that is basically you take this one, you combine this thing and this thing, you add and then minus you add this thing. Let's say this is what to say, diagonal 1. You add this together and then you minus this thing, you minus this one. Let's say diagonal 2. Okay, so you add one diagonal, you minus one diagonal, so you will get something like this. You get something 92 plus 94 plus 88 plus 90 divide by 4, because you have 4 experiment there, and then you minus this thing, 88 plus 91 plus 93 plus 91 divide by 4, and then when you do this, let me bring this here so that you can see that. Okay, so you will get the result around 0.25. So the value that you see there, 3.25, 0.75 and 0.25, we call it effects. Okay, so that's basically the result. We can say result lah. Okay, the result of factorial design. So from this, what we can say, what we can conclude. So here we can conclude that the driver effect, because this 3.25 is larger than others, so we can say that the conclusion, driver effect is larger than either ball effect or interaction effect. Okay, so that's what does it mean. So it's not necessarily if you have factor they are interaction. So here they are interaction, but they are so low, so the driver play more effect, contribute more to the response. So that's why if you do this DOE style, you can see whether the interaction matters or not. If you do OFAT, for sure you don't see anything lah. So that's one of the advantage of the thing. So this is, we can call it just a basic statistical testing lah, because when you do this thing, is basically you find the average. The average also part of the statistic. It's just to find the effect of effect of contribution to the response. So how far is from zero. Okay, so from here we can say there are strong statistical evidence that what we call that the driver effects differ from zero. Here 3.75, and the other two effect is not. So hence the experiment indicate I should always play with the driver that is oversized. So that's what does it mean here. So we can, this is only 2 by 2 if you have two factor, right? If you have two factor, ball and driver, that's fine. What about if you have three factors? These two factors. What about 3 factors? So let me put them. Okay, let's say now you want to check 3 factors. So you want to check what? You want to check driver, ball, and also the what we call the beverage. Let's say this, the beverage. Let's say you want to check these 3 factors for the response. So basically you can make a Cartesian coordinate like this. Let me make it bigger. Okay, so you can see, right? Okay, so you are basically adding another what we call axis to the design space. And then now if you do like this, you will see that your what we call your let me, how cantik macam ni. Okay, so if here you can see the square, if you do this you can see something like this, the what we call the cube, because if you put the cube here, so it's basically you put the cube here lah. Put cube here, tak cantik lah. Wait okay. Okay, so basically you are making the cube like that. Let me put there. Okay, so basically you are making a cube instead of a square. Now you're making a cube because you have 3 now. Okay, so that's how you ni lah. This design is called, because you have 2 level. So normally when you heard about 2 level, you use only low and high, because you see here this low, this is low, this is low, this low. Let me put in the ni lah. So you can see the green one is the low lah. The green one, this and this is low, and this is the high lah. So you only deal with 2 level here. So there are 2 level, and how many factors? You have 1 factor here, you have 1 factor here, you have 1 factor here. So we call this as 2 level. So 2 to the power of 3. Okay, to the power of 3. So this is 2 power of 3 factorial design. Factorial design. Okay. So basically the driver effects, so if you see here, the driver is from the right to the left on the y-axis. So basically if you want to find the driver effect, is something like this, driver effects. So let's say I put it driver effects, and then you have what we call driver effect. You have ball effect, and then you have beverage effect. My self is here, let me put here. Okay, so basically when you find the driver effect, because so let's say I draw something like this cube. So if you want to find the driver effect, you just basically minus this thing lah, minus this. Driver is left and right, so basically you just minus this and this. Okay, and if you want to find ball effect, ball is on the y-axis, so basically you do for the top and bottom lah. So basically you just top and bottom here, so ball effect. So you just minus top and bottom. And similarly for the beverage effect, you basically what we call from the front and the back lah. So you have front here, and then you minus the back here. So basically same like before. And the interaction you just do all the diagonal thing together as one by one lah, because for interaction you have interaction between driver and ball, and also interaction ball and beverage. So you do one by one lah. Okay. Okay, so that is the effect. So this factorial design here, when you see here, the factorial design here, when you have 2 by 3, the term 2 by 3 is to the power of 3 factorial. So 2 times 2 times 2. So it's also correspond to the number of the run that you need to run lah. So you get what? 2 to 2, 2 to 8. It become, you get 8 lah. 8. So you get 8 ke? 2, 3, 4, 5, 6, 7. Yeah, 8. Okay. So you get what we call 8 ni lah. 8 this thing. If let's say you want to perform this from this 8 experiment, you already get this interaction and so on, because you are combining all the nodes. If you use OFAT, what happen if you use OFAT? If you use OFAT, your design will be something like this. Your design will be something like this. This is when you use OFAT. Okay, this is when you use OFAT. Because when you use OFAT, you need to do it like this. You need to, if you let's say you use OFAT, what happen is that you need, in order to get the same data, the same result as a DOE here, you need to run more, because you need to run, for example, you have driver, and then you have, for example, at the high level, let's say I put this high level, or maybe put this oversized driver. You need to test it with the 4 thing. You need to test it with the low ball, meaning that low level of ball, high level of ball, and also the what we call the beverage is low level of beverage, and also the high level of beverage. And that's only for the oversized driver. You also need to consider also for what we call for the regular driver. Also you need to go the same thing. So let me just copy this thing. Control C, Control V. Yeah. So I just put here Control V. Yeah. So you have this thing. So you need to repeat this thing. So basically, you can say that this oversight, the oversight here is we can say this low level, right? Low level. This high level. So now you have basically what we call, you have oversize and driver. This is between driver and ball, and driver and beverage only. But what this already take you 8 experiment dah. Only take you experiment. But you need to also consider there are also the you need to also do the experiment between the ball and the beverage. You need to consider this also, because for time being you only see the driver and other stuff. You also need to find the interaction. So all in all, when you consider all the interaction, you will end up with 16 experiment, because each what we call, each factor you need to at least what we call at low level, for example at low level here, you need to at least perform 4 experiment. Okay, so all in all, when you consider all interaction, you can see here at low level, so at low level you need to 4, high level you need to 4, high level here you need to 4, high level here you need 4. So basically you get 16 experiment in total lah. So this is OFAT unit 16 experiment compared to this what we call, compare this to this thing. Okay, compare this thing and this thing. So you can see you can finish your DOE in half of the time compare when you do OFAT. This is where the efficiency come. The more the what we call, the more the number of factors involved, then the DOE have this significant advantage lah. You can cut more time lah. So you can also, this is 3 factors. What if you want 4 factors? For 4 factors, let's say I put it 4 factors. 4 factors. Okay, 4 factors is the design space is like this. The design space is like this. You just make the cube, the one that you learned before, make a cube, and then for example you want to consider all the factors we know before. We want to, the factors that we interested: driver, ball, travel, and also the what we call beverage. So basically the design that we see before, this thing, the one for the 3 factors here, ball, beverage and driver, you can extend it if you want to include the what we call the walking or the mode of travel. So you just do this thing like this. So this like 2 cube together and then you make like this. Actually it's hypercube, but to make easy you draw like this lah. Okay, generally if you have 2 factors, so if you have 2 level and then k factors, the number of run is the more k factors, the higher the k, meaning that the more runs lah. For example, the factors, so for example 2 to the power of 4, you need to run of 16 run. For example here, if you calculate, you have 1 2 3 4 5 6 7 and 8 times 2, then you get 16 run. If you have time, but this thing it can rapidly increase lah. For example, if you have 10 factors, 2 to the power of 10, you already get like 1204 runs. So this is what we call impractical lah. In real life is almost impractical to do this thing, but you don't need to do all full, what we call full factorial. This what we call full factorial lah. When you consider all the experiment, we call it full factorial. When you consider all the combination, we call it full factorial. But as I said, if the factor goes up more and more, then the number of run also increase rapidly. So you don't need to do full factorial in all the case. In fact, it's impractical to run like 1000 experiment. If you do like master or PhD, it's impossible to do that lah. So what you do, you can use a fractional factorial design, meaning that you just take a fraction of this thing. For example, let's say this thing, the mode of travel, this one, the fourth, you can make a fractional for this by just looking at what we call at certain nodes only. For example, let's say here, you just do this, and this. And then also, let me put green lah. Green is easy. This. Okay, this is not. This is let me put 1 2 3 4. 1 2 3 4. Yeah, correct lah. This thing. And then also you can do this and this, and then this, and this is not right. Yeah, they are combination. This is combination. This, yeah, this and this. Let me. Okay, so you can see here, you just choose the node, not choose the design itself will choose for you lah. I mean, it just like balance lah. So for example here, if you do fractional for 2 times 4, so this what we call 2 to the power 4 design, you get 16 run. If you do fractional, so you are basically doing 1, 2, 3, 4, 5, 6, 7, 8 run. So this is what we call how you do fractional lah. Okay, so basically that is a basic idea on how the design is, how the DOE designed the experiment, especially here for factorial. Factorial is basically the basis for DOE lah. The other design is just an extension for the factorial. You understand the what we call the factorial, normally you can easily understand the RSM and so on. Okay, because the RSM, the purpose, the idea of RSM, the response surface methodology, later on we will discuss, is basically they put the center point in the middle. Okay, so that's we will talk about RSM before, but later. But for now, this is how the DOE designed the factorial experiment in space. Okay,